I want to talk about exception handling in C Sharp, specifically in the form of a try-catch block in C Sharp. Now, to do this, I want to show you a program that I made here. It's a simple console application that takes user input, tries to parse it as an integer, and then we'll write that number to the console. So if we run this, let me slide this over here, and we put in a number or an integer, 101, it's going to take that and parse it correctly and spit it back out. However, if we run this again and we try to, let's say, put in text like hello, it's not going to know what to do with that. So what's going to happen is you see we throw an exception, a system format exception, specifically at the int.parse spot. Int.parse assumes that the string you pass into it is a valid integer. And yes, there is an int.TryParse to safeguard against this exception, but for the purposes of this video, we're not going to be talking about that. But I will link some documentation around that as well. But you can see that the exception is thrown, but the user doesn't see anything on their side. The program just kind of blows up, which is not the best experience. So if we want to introduce exception handling around this block of logic, what we can introduce is a try-catch block. So to write that out, you want to write try, and that's a keyword, so it's a code snippet. So if you hit tab twice, you can actually auto-generate that. If you want to write this out manually, you can do that as shown on the screen, but if you want to do it, again, it's try, and then hit the tab key twice, and then it'll auto-format that. So now what we can do is we can move this block of logic, this int where we set the int number, inside the try. And the try is going to basically do what it sounds like. It's going to try to execute this logic, and if it passes, it's not going to, if it doesn't throw an exception, we're not going to ever hit this catch block here. But if we do throw an exception, which we will, it's going to get kicked inside this block of code here. And you can see that we have this keyword, we have this word exception here in the catch. You can specify what kind of exception that you want to catch, but if you leave it just exception, it's kind of a catch-all for all exceptions, or most exceptions. But if you want to actually see what the exception is being thrown and return that in some form of logging statement or back to the user, you can introduce a variable, so ex, like that. You can name it whatever you want. It's just a variable name. So then we can say, let's go ahead and log, or let's go ahead and write that to the console. I was hoping I would get there we go. And let's write that exception out. And then you can see that in our method, we return a nullable int. So what we can do if we want to just continue the flow of the program for this purpose, we can just say return null. And then let's go ahead and remove this last return because that's not being used anymore. And we have to add a return statement to return the original number. So what we have just done is we have taken this original logic where we were throwing the exception, and we introduced a try-catch block around that logic. So if we were to type in an invalid integer into our program, it's going to catch the exception right here, and then it's going to execute this series of logic. And we return null. So the program is going to continue as it normally would. So let's go ahead and run this, assuming that we have everything right, which I think we do, and let's see what happens. So again, the existing logic is not going to change if we type in 101. It's going to do the same thing. But let's go ahead and type in text, and let's see what happens. So now, instead of it blowing up inside my Visual Studio, we actually printed the exception back out to the user. And we could program this so we could loop back and just keep asking for until we get a valid integer. We can do whatever we want, but this is really powerful because it allows us to potentially introduce logging into our application. We can introduce new fallback logic in the event that we do throw an exception. This is just a standard of software development. You have to build your applications in a way that allows there to be some handling of unexpected exceptions, which inevitably will be thrown. It's a little tricky to write these well in a larger application just because of return types and things like that. But this is just the basics, so I would encourage you to experiment with it. There's a lot of ways, to get familiar with these. There's a lot of, I think, ways you could practice writing these. But again, this is just one example of it. And the thing I was mentioning earlier, if you were to do, if you wanted to use a different set of logic for the int.parse, there is something called TryParse. So if we define, let's define a number, and then we define a Boolean is integer, we can call int.TryParse, and you can see it takes in a string, so we can pass in text, but then we can also return that number just like that. So basically, this line is essentially running kind of a try parse in the background, because if it's not a valid integer, it's going to try to parse that, but if it doesn't, it's going to return false back to this variable here. So is integer will be false. But again, you can look that up if you want to. I just wanted to talk about it really fast, just to make you aware that it does exist. So I know it exists out there. But yeah, I'll link some stuff in the comments or the description below. But yeah, that's all I got for exception handling. So if you have any comments, suggestions, any other topics you want to see in the future, let me know. Yeah, anyway, thanks. Bye.